Hi, today our focus is going to be on data. This is the central concept when it comes to the field of AI and data. And it is very important you understand this concept because it is central to everything you're going to do in the field of AI and data. Just from the word data, it means it's central. Even the AI we are talking about today, so the artificial intelligence we are talking about today, if there is no data, there is no artificial intelligence. So everything centers around data. And for us to have, let's say, do good data analysis, so if you have to do good data analysis, or maybe, like I said, AI, or you want to do prediction, or whatever you're thinking of doing, it boils down to having quality data. Yeah. So first of all, the data, you need to have the data, and most importantly, you need to have quality data. For me to explain this concept, I'm going to use a hypothetical example. Assume that you have been hired, or maybe you have approached a business guy who is somehow just having, let's say, a grocery shop or a business that deals with sales and purchases. And he or she wants to leverage this concept of AI and data, or you are proposing that this guy, which is a business guy, okay, so this is our businessman who is interested, or you think you have approached that guy in order to introduce the concept of AI and data because you know the importance of it. Now, this guy has nothing, knows nothing about AI and data. It's your responsibility to educate this businessman about AI and data. That is why at this stage of the business, or maybe you are approaching this businessman, it makes no sense to be telling the guy, I'm a data analyst, or you are what data scientist. All of these things don't make sense to this business guy. That is why it is very important that when you're starting your journey, forget about all these titles: data analyst, data scientist, business analyst. Yes, on job profiles, they are going to say they need a business analyst or a data analyst. But if you are approaching someone that has no knowledge about AI and data, then you don't need to be telling the person I'm a data scientist. You need to put it you need to express yourself in a way this guy can understand. Okay. Now, if you approach a technical businessman who understands all of these rules, then it's okay. But if you if you're out there to get opportunities, this doesn't make sense. So you might just tell the businessman, I can help you to improve your business using data, or I can increase your sales by 20% using some techniques in AI and data. When you position yourself like that, then you are not in because technically a businessman is not interested in all of these your titles. Now, in this in this our hypothetical example, this business guy has nothing. He has no computer. All of his business has been done on paper. Okay, so this is the condition before. So it has been paper based. The reason why I'm using this example is because this is how I started. And for those of you that are based in Africa, you realize that most of the businesses, even the hospitals, even most institutions don't even have a computerized system. And you cannot be talking about AI and data, meanwhile, you don't even have data. If you have data on paper, it's still not, that is data, yes, but when it comes to data analysis, you can't really do much. So when you approach someone that you want to help with AI and data, then your first responsibility should be how to generate that data electronically. So we're looking about electronic data, right? Electronic data. So you have approached your business guy and he says, okay, I'm interested in this AI and data thing, but I really don't know much. So your responsibility now is to look at the current paper-based system and transfer the data into an electronic system. I'm going to give you a very simple illustration of how normally a businessman might be, let's say, managing his or her sales currently. So you see they'll have a piece of paper, or let's say a document or a book where maybe they have the date of sales. I'm going to keep everything in abbreviation: date of sales, and maybe the item, then the sales price. What else? So this is the sales price, and Yeah, so the date, let's say this is this for some, let's say this, then the sell item X, sales price is this, um, um, like this, okay, and maybe I'm just giving examples, okay. Now, so this is what we have. Now, before you even think of doing, let's say, doing data analysis or visualization, there is nothing you can do if this thing is let's say, in a book or in a register. There is nothing you can really do. What you need to think of is now taking this to a simple form of data management. And when you're approaching someone, your responsibility is not to advise them to start um, investing so much in technology, because take note, the goal is not the goal is not to talk about so much technology. The goal is to show that you can help someone. At the end of the day, this guy just needs advice. And the more you start, if you start think maybe proposing high investment in electronics or in infrastructure, then you might not even get to the endpoint, or you might not get to the endpoint. So normally, the first advice is you're definitely going to buy a computer, right? So this guy, normally you're going to need a computer. And in that computer, then we will need you to install, if I'm the one to advise this, I'll say, let's start with an Excel sheet. When you go to an Excel sheet, you see, normally you're now taking this register and you're putting that into an Excel sheet. So basically what you can just do is simply you look at the way they have structured their data management in a register, right? So if this is the sales, then you have an Excel sheet where normally it's going to be an Excel workbook. So this is a workbook, and in a workbook, you have sheets, right? So maybe for sheet 1, you store all the sales, and for sheet 2, you store all purchases. So these are purchases from suppliers. When you start doing this, then you notice that you realize that you are now generating data in electronic form, which for those of you who know how to use the R, the Python, the Power BI, then you can now import this into your favorite tool. But before you think of doing that, be very careful, because the way you also structure your data really matters. And when you want to do analysis, there are certain things you're going to need in order to run a good analysis. So the first thing, you just probably copy and paste or use the same structure as the Excel, as the register. But when you're doing this, you need to realize that there are certain other data points you need to capture. If I need to run analysis on this, for example, we know that the date of sales has been captured, the item, the sales price. You realize that there is something lacking. Our businessman might be interested to know the customer, right? To know the customer, and maybe also what was the purchase price of this item. So when doing this process of transferring from paper-based to electronic, then you need to start thinking of other data points that might be important in your analysis in the future. So when you have your Excel sheet, so I'm just saying that try as much as possible to really ask good questions at this level that will help you to capture as much data as possible. This process that we are currently doing is data management. So you hear someone say, I'm a data manager. So I'm a data manager. This is technically data management, right? Data management just means you're trying as much as possible to capture quality data. Now, these guys, they were actually doing data management before, which is having a book or register is the data management. But what you're now doing is called the electronic data management. The fact that you're using Excel sheets, then it is electronic data management. So technically, you're just becoming a data manager here, and it's still part of the responsibility of a data analyst or a data scientist or whoever you think you are. Because if you don't have the data, then there's nothing you can do ahead. So this is electronic data management, and I've just explained to you one form of it, which is using an Excel sheet. Now, Excel sheet is a very simple way of doing data management. Always start from there. Then when you see the need or responsibility or the necessity to upgrade to other types of data management systems, then you can definitely move ahead. Now, there are drawbacks of using Excel sheet. With Excel sheet, you basically know that someone can just go onto your desktop or your computer and just click on delete and everything is gone, right? And this is not a very good way of managing data. And another form, if your manager or you guys have the technical know-how to move to the next level, you should be thinking of using a database system. Database system. And there are several types of database system, but I want you to maybe you already know, but you need to know about relational database systems. With relational database systems, it's just like you have so many. You take an Excel sheet in this format, and you split them into several tables. So this could be a table for sales alone. This could be the table for the items. This could be the tables for purchases. This could be, it can be another table for customers. Yeah. Then because it's a relational database system, then you know that for someone to make a sales, there must be an item. So the item is related like that. An item is related to this table. And for customers are related to sales, right? Then maybe you have another table for suppliers. So you see that suppliers are related to purchases. So basically, that is how a relational database management system is being structured. It's just, you can take a whole Excel sheet. The fact that it's in one big Excel sheet, it's not good for data management technically. But if you want to move to a more sophisticated level, then, or maybe thinking of using a software where people like your secretary or the sales guys can just using a graphic user interface, they can enter data, then you should be thinking of using a relational database management system. So this is still part of database management, right? But moving to a database management system, then you wear the hat of a database designer. And database designer, you could be a database developer. You could be a database developer, and obviously a database administrator. So you see how the different roles are playing in, right? So in a very big company, these are three separate roles. But in a small company, you might wear the hat of, you might just be, they say you are the guy responsible for data management. So you know, okay, you have to design the database. But fortunately, design of the database will happen just once. So when you design your database well at the beginning, you have to develop it. And when it's being developed, the only thing you have to do is doing the maintenance of the database. So making sure the database is being backed up on time. If someone needs access to a table or something, you are responsible to give that person access. So this is still another form of database management. But before we move ahead, I really want to emphasize that so far we have been looking at just structured data. Structured data, right? Structured data means it is well structured. You know, okay, there are going to be 10 data points I want to collect every time, or 20 data points. But there are other forms of data that this guy might be collecting. So maybe like stuff like, let's say, receipts, or other documents in the company that these guys are keeping, maybe in a Word format or whatsoever. They're just writing reports in, like a report in a Word document. So these are other forms of data, right? Which are, these guys are unstructured data. And for unstructured data, you're going to need other forms of analysis. But for now, let's focus on the structured database. So I hope you're following up. So you see that when you start, if you're starting with someone that has nothing to do with database or has no data, then you should be thinking about electronic data management. And then you also have the database design. Now, we are now at this level where we have a good database design, right? We have data flowing in. And the next responsibility is, maybe the business guy will say, okay, I see that you have helped me to have a database, in that case, a software where they can manage my data. But for you to advise this businessman on what maybe this item is selling well, or you want to predict the sales for the next 6 months, you need to move to the next level, which is now the data analysis part, right? So we move to data analytics. Data analytics. The very obvious one is you start by asking. So your responsibility before you run any analysis, take note, it is not you making the decision. You need to ask the business guy, what are the type of things you want me to answer based on the data we have, right? So we start doing business requirements. So business requirements, I hope I'm spelling this rightly. Yeah, business requirements. So business requirement could even start from the level of you asking questions, even at the database level. But gathering business requirements, on paper, you are now becoming a business analyst. This is one role of a business analyst, okay, where you actually gather business requirements. So you move to the boss or to the stakeholders and say, okay, now we do have data. What are the business questions you want to answer? They'll tell you we need to answer questions about what has been our sales for the past 5 years, what is causing us not to make profit, what is going to be the sales for the next 6 years. So those kind of business questions, so you are asking business questions, they will tell you in their normal language, and it's your responsibility to transmit these business questions, and you present them to the business analyst, or you present them to the data analyst. So technically, if you are working in a very big company, the business analysts, most of the time, they don't really have to be technical. Their responsibility is just the middleman between the stakeholders. So you are the middleman. So you're here. You take questions from the stakeholders, and you transmit them technically to the business, to the data analyst. Same wise, when the data analyst comes back with results, it's your responsibility to go back to the stakeholders and present the results. In a very small company, this business analyst and data analyst is just one role. So it's your responsibility. You could still do this. It could still be like this, where you, the data analyst, you ask the questions directly to the stakeholders, come back with your beautiful dashboard or whatsoever, and you present your results. Okay, I hope you're still following up. I know it's quite a lot, but now we already have our data and we want to do some data analytics, right? So you ask the business questions and they say, for now, we just want a very beautiful dashboard where maybe at home, I could, as the businessman could say, I want to be at home, or maybe when I travel abroad, I want to be able to see my business using my phone or using something. Now that brings, when I say using my phone and the guy is abroad, then there must be some sort of internet, must be over the internet. And I want to bring you back to this database management system. If this database management system is local, then it might be challenging for us to get data out of it over the internet. So when the businessman starts saying, I need to see my data analysis over the phone, then for the data management part, you need to think of taking it to the cloud. This is where cloud comes in, cloud technology. If you haven't watched my other video, the previous video, I took some time and I really elaborated on cloud technology. Go back, pause this video now and go back and watch the video about cloud technology. But cloud technology is just simply what we are doing offline. We take it to the cloud so that no matter where you are in the world, with an internet connection, you can have access to your data. So in this case, we can move the database that is local and we send it to the cloud. The reason why we're sending to the cloud is because we want the software that they are using maybe at the shopping center to be able to access the data. At the same time, you want to run analysis, you should be able to use the same database, right? Okay, so now that's what we have heard, that one of the requirements is they want to be able to see analysis live. And even when abroad. So even when abroad, they want to see analysis. And for that to happen, like I said, you have to move online. And so now, before you do analysis, I'm just giving you the ideal situation. Okay, now you now have this database that has been designed. Take note, this is a relational database. If you go deep into analysis, you realize that this structure, this relational based structure, is only ideal. So a relational database management system. This is a whole topic on its own. So if you're interested in database management system, you need to know this, or even you're interested in analytics, you need to understand this. It's good for transactional um, transactional data. So if you have data flowing in every second of the day, then this is a good structure or database management system to manage such data. For example, you are in a shop, it's a very big shopping center where every second someone is buying something, maybe online or maybe at the shop. You don't want to use the same database for analysis, because what if they ask you to give us analysis from this time to this time? As you're doing analysis, there is someone using the graphic design interface to take out, to maybe to modify data. So what do you usually do as a data analyst? Not it could be as a data analyst, you have to transfer this into what is called a data warehouse. A data warehouse. It's also called a lake, data lake. Data lake. And these types of data management systems, they are good for analytics. So these guys are good for analytics, and they use a special type of schema. So in this case, it was called relational. For data analytics, they use the star schema. So that's why when they say you're doing your visualization, there is a part where it's called modeling. So the modeling is what have you done to model your data. You have the data in the relational format, but before you run analysis, you must change from the relational model to a star schema. This is another big concept for another day. For another, if you're interested in data analysis, then you should be talking about data schema. So when it comes to modeling, like I said, it's a topic for another day. It's a topic for another day. Now, so if you want to do data analysis, ideally you should convert your relational model to a star schema, and you can use technology such as, it is data warehouse or data lake. When your data is in this format, then you are good for doing data analysis. You could also do it in Power BI. For those who know how to use Power BI, Power BI is very good at that as well. If you're using maybe Python or Arrow, then somehow you have to maybe do in Python, but I won't really advise that. So before I move on, the process of transferring data from, let me explain, the process of getting data from a relational database to a data warehouse, and maybe from other sources. Remember, I also spoke about unstructured data, right? You want to bring unstructured data, and maybe you have several relational databases. So doing this is what is technically called data engineering. So as a data engineer, ideally your responsibility will be to take data from from the different sources from different data sources, and you bring them to one central location. The reason is because as data analyst, your responsibility will just tell me where my data is, and then I'll run my analysis. But companies do have several databases. If you're working in a very big company, they'll have a database. So for example, they'll have a database for finance, they'll have a database for employees, they'll have a database for their own sales, they'll have a database for maybe purchases, they'll have a database for other things. So as a data engineer, your responsibility is to take all of these different data sources and you put them into a data warehouse, so that people like your business analyst, your business analyst, your data scientist, machine learning engineers, machine learning engineers. These guys, they all work using data coming from a data warehouse. So they don't have to go through looking at the different data sources. They have a central location. So this is your central location where everything is found. Take note, I'm just giving you this situation. If you're working in a small company, you might not need to do this, but I'm just explaining in such a way that if you're working in a big company, then you need to understand how data flows. So now we are at the level where our data is in the data warehouse, and the business analyst has asked the critical questions about what we need to do, and they're saying, okay, now we need to develop a dashboard. So if you need to develop a dashboard, that is a responsibility either of the data analyst or the business analyst, or still even a data scientist. Like I said, for me, I'm not interested in calling titles. If they say dashboard, as a data scientist, you can also be a dashboard. So let's say you want to be a dashboard. So if you need to do data analysis technique, I would usually say you just want to do visualization. And there are several ways of doing visualization or several tools. So what you should be mastering is visualization, because you can use tools like Python. You can use Power BI. You can use Tableau. You can use Arrow. If I haven't named your favorite tool, please understand that, yeah, the list is quite long, but those are the things you need to do. So using either of these tools, you can actually do your visualization. So you have a dashboard, right, where someone could see the sales going up. They could have a pie chart like that, or a bar chart with sales. For those of you who are good at visualization, those are things you need to understand. But take note that the businessman requested that he or she wants to see the business while abroad. So a good tool to use is Power BI, because Power BI already has those things. Power BI has the Power BI desktop. It has a desktop version where you actually do the data work, right? You have the Power BI service, which helps you to publish your dashboards in the cloud. And you have the Power BI mobile version, which your manager can see it using the mobile version. So maybe you can think of that as well if the boss has money for it, because obviously you have to pay licenses, right? Tableau is the same thing, but with Python and Arrow, yes, there can be some packages that you can install in order to deploy it in the cloud, but it will require some advanced skills for you to be able to deploy these things in the cloud. So that is that. If you have to do visualization, then that is the mindset you should have. Now, the manager or the boss is interested, is quite okay with the results they are seeing so far. Technically, when you're doing visualization, you're just telling them what the business is doing. So, or what are the facts of the business? There is nothing you're saying into the future. Now, this business guy is quite interested in, or so far, he's happy with what you have done, but they want to see what happens in the next 6 months of the business. That is when you start talking about prediction. Okay, you want to predict the future. So based on the data we have, what is going to happen in the future. You cannot do this if you don't have data, if there are enough data. So technically, you are now moving into the world of machine learning. So machine learning, the whole idea of machine learning is just discovering patterns in data and predicting what's going to happen into the future. So before you start thinking of machine learning, then you must have gathered so much data over the years in order to be able to predict well into the future. Yeah, as a data analyst, this might not be your responsibility. This is now the responsibility of a data scientist, ideally. So as a data scientist, you start looking at machine learning models, how to predict what is going to happen into the future. I'm not going to go deep into this as well. Yeah, you can now use Python. You can use Python in order to write your machine learning models that will help to predict into the future. Microsoft Azure also has a machine learning platform where you can do everything there and also deploy your services. I think also AWS, all of these guys, they do have very good platforms to do machine learning. So like I said, machine learning ML is just for you to be able to predict what is going to happen to the future. Now, when you do this as a data scientist, ideally in a big company, let's say you are training a model, your model is ready, and they want to deploy this thing live such that when as data is coming in, it can predict the future. That is now the role of the machine learning engineer. Machine learning engineer. So as a machine learning engineer, your responsibility is to take the model that has been trained by a data scientist and you deploy it. So deploy it to the cloud. So deployment just means you want to take the model and put it live such that as data is coming in, it goes through the model, then it does prediction. So technically that's what you're doing. And to be able to do deployment, then it goes back to the cloud technology I mentioned already. You need to do this cloud technology. Another good example, let me just take you away. If you have a Netflix account, let's say, or you're shopping or you're doing something, by the time you buy an item X, these guys already start proposing you item Y and Z. So what is that? Based on your purchase history, they are already predicting what thing you can buy next. So that is also like doing some suggestion is machine learning. That is a good example of doing machine learning. So basically that is that. There are other roles and responsibilities that you can do when it comes to data. I haven't spoke about maybe infrastructure engineer. Infrastructure engineer is like, okay, guys that will actually maintain your infrastructure in the cloud or on-prem. Wow, I know we have covered quite a lot, and I started just mentioning data, and we have gone this far. So maybe just a recap of what we have done. So back, I said for you to get into the field of AI and data, you need to understand that everything centers around data, and not any kind of data, but quality data, right? So we need to talk about quality data, and you can maybe join a business. Your first job or something, or your responsibility will be to maybe help someone that is currently doing paper-based system in order to do the transition from paper-based right up to the point where they can use advanced AI and data techniques. So we gave an example of a businessman that is currently doing paper-based system. I mentioned that this is how normally they would do if they're actually doing some registration book. The next thing you should be thinking of is using an Excel sheet, just simply copying what is there and also have it in Excel. And that process is called data management. So you want to do electronic data management. Now, Excel has its own limitation. If you want to move advanced, next you're thinking of a database system, more specifically relational database management system, because there are other types of database management system. And I showed you this is normally how a relational database management system is structured. This is a whole topic on its own, so you have to maybe go deep into relational database management system. And I said for you to manage this, you could be they say they will need a database designer or a developer or an administrator. I said this relational database management system is good for transactional data. The reason being that transactional data is like data that is coming in and going out very, very fast. And you don't want to use the same transactional database management system to do your data analysis. So this database management system is being transferred to another type of database, which is they are called data warehouses or data lakes. And they have a special type of schema, not the relational, they have a star schema. So based on this star schema, right, you can now do your analysis. But the process of transferring from a relational database to a data warehouse, so I tried to illustrate here. So from the relational database or from other unstructured data to a data warehouse or a data lake, this process is called data engineering. So in a big company, it's the responsibility of data engineers to actually take data from different sources and bring them to one central location. you hear them say they are doing pipelines. Okay, so you do pipelines, and when the data is in a data warehouse, that's where the data analyst or business analyst or data scientist or machine learning, that's where they pick up the data from. And as a data analyst or a business analyst, when you ask your business questions, when you go to the management, you ask business questions, you now come back and say, okay, maybe they need to do visualization. So they need a visualization dashboard. You should be thinking of tools like Power BI, Python, Tableau, Arrow, depending on what you need. If they say they want to go to the cloud, then Power BI and Tableau, they already have these things incorporated. It's going to make your life easy, but understand that you have to buy the licenses for these tools. If you are using Python or Arrow, you could do it with Python Arrow, but know that you have to do a lot of manual work yourself. Now, when they have a visualization dashboard, it only tells them the facts of what has happened in the past. If you need to talk about what's going to happen to the future, then you are moving into prediction, which is the world of machine learning. And this is where data scientists they come in. So that with data scientists, you must understand different machine learning models that can help you to do prediction. Same, you need to have a very good understanding of Python, machine learning models, or machine learning tools such as Azure ML, Azure AWS ML. You can use Python. They use Python quite a lot. So at the end of the day, the data scientist, even though you can still do visualization, you do machine learning, you have your model, which you now hand over to a machine learning engineer. As a machine learning engineer, your responsibility is to deploy it to the cloud. So deployment, you take the machine learning model and you deploy it to the cloud such that as data is coming in, there is live prediction. So prediction happens. I gave a good example of Netflix. As you watch a Netflix movie, the fact that they realize that you have watched movie X, they can already propose you movie Y and movie Z. So something related to that type of movie. Same thing if you're shopping online, that what also happens. Even on Facebook or even on YouTube that you're watching this video, as soon as you're done watching this video, depending on the content of the video, they already propose you the next videos to watch. So guys, that is that about data. Quite a lot. I hope you do have a good understanding. Remember, if you do have any questions, don't hesitate to drop them in the comment section. And also don't forget to like and share the video if you found it interesting and insightful. Thank you.